Hello, hi everyone. Welcome to my channel STB Academy. Today we are going to discuss about the topic is CBSE Grade 10 Physics Ohm's Law. So Ohm's Law activity. So we are discussing in this video. That is nothing but you can see here. So Ohm's Law is nothing but simply the potential difference. The potential difference across a given metallic wire. So you can take this given metallic wire, you can consider this some given metallic wire, or simply called as any metallic wire you can consider. So this is one point I am considering, one point. So here, and another point is here I am taking here. So the potential difference across a given metallic wire is directly proportional to current flowing through that. The potential difference means, so across this one, the potential difference will be there across this given metallic wire. So it is a given metallic wire, and so the potential difference is directly proportional to current flowing through it. Okay. So at constant temperature, so that we have to prove. So in the activity, how to do the activity. So this is our no, the aim also, our aim also will be the same. Ohm's law activity, you can see what is the activity. So to show that the potential difference across a given metallic wire in an electric circuit is directly proportional to current flowing through it at constant temperature. Here it is very important, you must understand. So that we are proving, okay, so that we are proving at constant temperature. This is very important. You can, so you can note down here, this is very important. Remember, only these conditions are very important. The potential difference across, the potential difference, you can take the potential difference, okay, given metallic wire is directly proportional to current flowing through it. So is directly proportional to current flowing through it. Okay, so V is nothing but V is directly proportional to I. So we have to prove that one. So what are the materials required to do that activity? What are the materials required? Nichrome wire of 0.5 meter and an ammeter and voltmeter and 4 cells. So we have to take 4 cells. Each cell potential difference is, so 1.5 volts each cell you have to take. Each cell potential difference is 1.5 volts, 1.5 volts. Okay, then so how the circuit diagram will be there, so you can see here, this is a circuit diagram, first of all. So you have to consider, you have to take first given metallic wire. I already said. So what is the given metallic wire? In the previous case we took the given metallic wire. So here you can see this xy is a given metallic wire. So this xy you can take. So x and y is a given metallic wire, and so that is a resistor also. What is a resistor? This device which is used to oppose the electric current in the circuit. Okay, that's a device. Like resistance. What is the resistance? Resistance is a phenomenon of opposing the electric current. Okay, so here xy is a metallic wire, that is nothing but nichrome wire. We consider nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So nickel is an alloy, of nickel, you can see, sorry, nichrome wire is an alloy of what? An alloy of nickel. So you can take, yes, nickel, okay, sorry, yeah, nickel, chromium and manganese and iron metals, Okay, so it is an alloy. Nickel is an alloy. Okay, alloy. Li. So it consists of, you can observe here, so it consists of nickel, chromium, manganese and iron metals. Okay, it's a mixture, it's an alloy, right? So here I am considering XY is a nichrome wire of resistor. So what, how much length it is? 0.5, 0.5. So previously, so we mentioned 0.5 meters. So previous slide you can see here, nichrome wire of 0.5 meters, right? 0.5 meters. So like that we have to consider. Here I am taking XY is nichrome wire of length 0.5 meters and 4 cells we took. So what is the each cell potential difference? How much? 1.5 volt. So 1.5 volts. So here I took the, so 4 volts. 4 cells, 2 and 3 and 4. So 4 cells I have considered, right? So connected. 4 cells are connected. So like connecting wires are there. And next one here ammeter. Ammeter also I have considered. Next one voltmeter. Here you can consider voltmeter also there, right? So voltmeter also it is there. So you can observe on the screen. So voltmeter. Here it is the voltmeter, right? This is a voltmeter. Here it is ammeter and plug is there. Anyway, that is connected. So all these connected. This is a circuit diagram. This is a circuit diagram. You have to connect like this. You have to connect like this. Very, very important diagram. So make sure that you are drawing. So here, so electrical circuit for studying Ohm's law. Electric circuit for studying Ohm's law. So this is about the circuit diagram. This is about the circuit diagram. Next one you can see. So initially what we have to do, we have to connect. First we have to take one cell and connect. We have to take one cell. So one cell is nothing but 1.5 volts of one cell. One cell we have to connect first. So that's the reason you can see, you can observe the dotted line here. This is a dotted line. So first we have to connect one cell. Then you have to measure the reading of ammeter and voltmeter. Ammeter reading and voltmeter reading you have to measure. So that's the first step. And the second step, you have to connect two cells. You have to connect two cells. Cell 1 and cell 2 you have to connect and measure the same process. Ammeter reading and voltmeter reading you have to connect. So that is step 2. And step 3, next 3 cells you have to connect. So 3 cells and take the same readings. And 4th cell, so connect the 4 cells and take the same reading. Like that. So you have to take all the readings and tabular form you have to take. You have to mention in the tabular form. So listen carefully. So once again I will explain. So here first you have to take one cell. One cell you have to connect in the circuit. So across the total circuit will be the same. But first we have to consider one cell, right? Then you have to take the reading of ammeter and voltmeter for one cell. Okay. So the current passing through the nichrome wire, that is a ammeter reading, and the across the nichrome wire, that is voltmeter reading, right? So that is the first step. Coming to the second step, connect two cells. Connect two cells and take the reading of ammeter and voltmeter. Then third step is connect three cells. Okay, connect the 3 cells. Then you take reading of ammeter and voltmeter. Then again connect to 4 cells and take the reading of ammeter and voltmeter. Ammeter and voltmeter. Then so you can mention all the values in the tabular form. So here you can see, so serial number. So first one serial number and the next one number of cells. Number of cells what you have taken, number of cells used in the circuit, number of cells used in the circuit. So how many cells used in each term? So first cell and 2 cells and 3 cells and 4 cells used. Next one, current through the nichrome wire, current through the nichrome wire. So previously you see here, so in ammeter, okay, nichrome wire is through nichrome wire only, right? So the current will pass through it. then only we can able to measure the ammeter reading. So then voltmeter reading, here also the same. So while you are taking the tabular form also, you can consider current through the necrover I in ampere. Okay, what is the SI unit of current? Ampere, right? So then the potential difference across the necrover. So I connected already, right? So then you have to write the values. Then V by I ratio you have to find out. Okay, so you have to find out the ammeter reading and mention in each time, and voltmeter reading also. And the second step is, so find out V by ratio, V by I ratio. That is nothing but R, resistance. So we know V is the potential difference across given metallic wire is directly proportional to current flowing through it. V is directly proportional to I. So V equal to IR. V equal to IR. So what is R? R is nothing but so proportionality constant. R is a proportionality constant. So that is nothing but resistance. That is nothing but resistance. Okay. So I already said, right, resistance and a resistor. Okay. So what is the difference between resistance and resistor? Resistor is a device which is used to oppose the electric current. Resistor is a device. Resistance is a phenomenon of opposing the electric current. The phenomena is called resistance. So only the device is considered as resistor. Okay. So R is a resistance. So V equal to IR. Then V by I equal to R. V by I equal to R. We have to find out the ratio. So here, if you find out the ratio, that is constant, you can here you can mention the ratio. So after finding the current and potential difference, so V by I for each and every case you have to find out. Then you can draw a graph. Then if you draw a graph, the graph how it looks like, like this. So the graph appears straight line. The graph appears as a straight line. Okay. So when you are taking like this, here each and every time, first case V by I and that value, and second case also V by I, and third case also V by I, and fourth case also V by I. So then you find out that is a ratio. We can consider that is every time if you find V by I ratio, that is so you will get equal. You will get equal. Okay. So common, right? So then you have to take a I reading. That is nothing but ammeter reading. That is nothing but current on x-axis, so on horizontal axis. So voltmeter reading, that is nothing but potential difference. Potential, here it is potential difference. Okay, potential difference will be mentioned on y-axis, vertical axis. Then if you take the ratio V by I ratio, that is R. Okay, so that will get equal. So this is about the graph. So graph looks like a straight line. Okay, so the value if you draw it, like it appears straight line. Okay, so linear form also we can consider. That is a VI graph. Next one you can see, yes, the conclusion. So V by I is a constant for the given metallic wire at given metallic wire at a given temperature. It is called resistance. It is called resistance. So V by I equal to R. So V equal to IR. So this is Ohm's law. V equal to IR. Very, very important. Based on this one, problems also they will ask. And some important points you can see. Some important points. So here I given. So V-IGRAPH is a straight line, and VI is constant. That is nothing but V by I equal to R. And resistance. So what is the resistance? Resistance you can see. I already said resistance is the phenomena of opposing the electric current, the circuit. So it resistance. So it is a property of conductor to resist the flow of charges. So through it. And variable resistance. Variable resistance means, so previous video I given all the component symbols. That is nothing but rheostat. rheostat, that is nothing but variable resistance. So you can see the symbol will be like this, okay, or it is like this also, you can take like this, rheostat. So this rheostat, a component used to regulate current without changing the voltage source, without changing the voltage source, that it is called variable resistance, variable resistance. So V equal to IR, that is nothing but Ohm's law. V equal to IR, that is nothing but Ohm's law, and SI unit of resistance is ohm. SI unit of resistance is ohm. Symbol is like this. This is the symbol. Okay. Then nichrome wire is an alloy. So previously I mentioned nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. So these are the important points from this video. Thank you so much.